Swayam Prabha. Digital India. Educated India.
Good morning, welcome you all to the next lecture in this particular course on analytical, spectral, microscopy, applications of inorganic compounds and nanomaterials. In the previous class, I have been explaining you things based on the chromatography techniques. I have already explained you the basic principle of the chromatography. Also tried to convince you that the chromatography can be used not only for small molecules of organic, inorganic, you can also use for the large molecules of biological systems as well. And I try to build all the principles required, particularly those where we have the chromatography techniques of various kinds, like thin layer chromatography or column chromatography or Sykes exclusion kind of a chromatography, or ion exchange kind of a chromatography, and chromatography based on the affinity. I think with these 4, 5, 6 kind of a techniques, more or less you can cover the basics of the chromatography that is required in this particular course. And having covered all that, let me start moving on to the application or understanding or the process base. So what we have looked till now is the thin layer chromatography. These are the best principles of that. Then we have the column chromatography, and then we have size exclusion, and we have ion exchange, and we have affinity. So I have built all of these, the basic concepts, principle behind it, everything in the previous class. Now let us look at how these function, what you will get out of that, how do you explain a chromatogram that is coming out of these, etc. So let us look at the case that where the protein separation and purification. The proteins, when they isolated from cells, there will be an impurity of other kinds of proteins, as well as they can be impurities of non-protein other systems as well. So therefore one needs to separate as well as purify, and one of those techniques of course is the chromatography, and the one which I have mentioned here is a hydrophobic chromatography. So hydrophobic interaction chromatography, and then we also have the reverse phase chromatography. Let us look at the differences between these two or commonalities between these two. In the mobile phase that you use in the hydrophobic is the water, a polar solvent, and in case of reverse phase it is the non-polar solvent, not water kind of a systems. And in case of the hydrophobic interaction, the protein is not disturbed, protein is in its native state. And in case of the reverse phase, because you are using the reverse phase technique which is in the non-polar medium, so it will become the protein interactions, internal interactions which holds the structure breaks, and breaking that protein structure is basically referred as the denaturation. I am sure everyone knows the denaturation. If you are not, please have a look at the meaning, understanding of that from the literature, information that is easily available everywhere. And then so what kind of a properties are of the protein in case of the hydrophobic interaction case? So it is the surface residues, only those residues which are present on the surface. Suppose this is the protein, so you have some residues coming out, and this is this particular thing what you are talking about. And in case of denatured, so the protein will be open up, so then you have everything is open. So there is nothing called exterior or interior. So everything is open up. So all residues. So here all residues and here only the outer or exposed residues. So, this is the kind of thing that you have. This is the denatured state, this is the native state. Okay. So, you can see that. Now, that is how the whole thing goes. So, what kind of things that you use for the stationary phase you use? If it is a weakly hydrophobic, use octyl agarose, and if it is a somewhat medium level of hydrophobicity for the protein, that can be measured by other methods, and you use the phenyl agarose. That means you can temper, you can modify, you can modulate your stationary phase, so that they have a specific interaction, specific ability to separate those kinds of proteins, not other ones, though it is there, other things are there in the mixture. I hope that part is clear from the hydrophobic interaction of the chromatography versus reverse phase chromatography and the column material that you use in these ones. So, what is the kind of a principle or property based? So, if you are talking about ion exchange, obviously charge. So, the cation anion with the anion exchange. You are talking about gel filtration, is basically shape and the size. If you are talking about the hydrophobic separation, then you are looking at the hydrophobicity. Okay. In the reverse phase, you look at the hydrophobicity, but the total hydrophobicity, as you can see here, it is the total group's exposure, here only the exterior. So, the protein is already in a particular shape, and then you have the exterior part of that. Affinity. So, we talked to you about the affinity. There is for the column, you attach a ligand. Suppose this is your stationary phase column, then you attach a ligand. So, this ligand should be selectively interacting with one of the protein of your mixture, but not all of them, and that is what is the affinity I talked to you. So, affinity specific to some amino acid, not specific to another amino acid, etc. Adsorption. So, variety of these things that we have already looked at. And how do you get the proteins out? Let us say now you have put the protein mixture, you have already got onto the column, and now they need to. So, by changing the ionic strength, by changing the solvent or polarity, by changing some salt agents, these are called chiotropic structure breakers and structure makers, use the structure breaker kind of things. This is also very well known in the literature, and detergents and the pH variation. So, you can vary the solvent, you can vary the pH, you can vary the ion strength, you can vary the chiotropic salts, you can vary some kind of organic things which are detergents. Some of them will dissolve it, some of them will not. So, those which will not dissolve will come into out, and those which will dissolve will go into that. So, these are the kinds of things that separation when it comes to the protein. Okay, now ready with all the basics of the chromatography, the principles, how it functions. Now, when you run a chromatography experiment, so what you get out of this is called the a chromatogram. So, that is referred as the chromatogram. Chromatogram is like a drawn spectrum type, so which is coming out of this. So, we do not call it a spectrum. Okay. So, that is one of that is example is shown here. So, this if you take is the x axis. So, you can use on the x axis any kind of a parameter which is of the elution is the time you can use, or the elution gradient also you can use. Suppose you are using starting from a small ionic concentration like 0.1, then you go to 0.2, then you go to 0.3, you go to 0.5, etc. Any of these things can also be used, gradient, elution gradient, and any other gradient. So, if you are using a solvent, it is a polarity gradient. If you are using a proton strength, then it is a pH gradient. Any of those gradients can be used on that. And on the y axis, so you have the signal. The signal comes from the kind of a detector that you have used. So, this is the detector based. I will explain you a bit later towards the end of this particular lecture what kind of detectors are used, etc. So, for the time being you take that signal that comes out of this. So, therefore, you have the signal on the y axis, that means that talks about the strength of that particular thing or concentration of that particular peak. So, you can say at the end this corresponds to the concentration of that particular fraction. Okay. So, that is how it is. So, you start with, let us say you have your assume a column and then you put your solvent, you started collecting. So, that is the starting phase. So, there is no signal, that means initially only the solvent is coming or whatever the medium you are using and none of your protein, and then or another compound. Then slowly you see this is signal start growing. So, increasing signal, that means more and more of your compound or of your protein is coming out, and at a stage it goes to the peak point, means highest concentration is come at that stage. So, if you take this x axis, at this value of x axis you have the highest concentration of that particular fraction coming out, and then again as a function of time or as a function of gradient, as you use x axis, as a function of the x axis it goes down, and again at the end, that means you have already finished all eluting all your compound, and then only the mobile phase or the solvent or the this thing comes out. So, you can use time, flow rate, mobile phase, or any gradient, any of these things. So, even you can use the flow rate also if you do not have a gradient. So, then if you have a gradient you can use the flow elution gradient, all of these can be used. On the y axis you can use the detector signal strength is directly proportional to the concentration of that. So, what kind of detector signal I am going to tell you a bit later in that. Okay. So, this is referred as the chromatogram. Okay. Now, another way of looking at it, you take this as your column and this is your material that you have, you are pushing your mixture from here along with the mobile phase, it will go here, you see lighter region, that means only solvent or background, and as you keep going across towards the left side you see darker and darker and greater dark, that is exactly at the peak point. So, this darkness is increasing this side and decreasing this side. So, when you come from this side it increases, when you go this side it will decrease. So, again it became lighter, you can see that. So, the same thing, this triangular shapes signal is shown by this particular thing. So, you have entry at the mobile phase and the compound separation, less amount of compound, more amount of compound, maximum amount of compound, again little less and nothing. So, therefore, you have this will come as the last, this will come. So, the one which is on this side will come first, this will come next, the mid peak will come next, and these are so this is reverse order, that is what you see. And whatever is coming, it is going through the detector, and detector give you the signal, and the signal is connected by your computer, and the computer will make the data, and the data will be used for making the plot. And the plot is referred as the chromatogram. That I hope that is clear, what a chromatogram, what is a chromatography, etc. Now, let us look at some most commonly used in the literature by students, by the researchers, by the people in R&D, in the industry, everywhere. So, a few of the techniques that we will look at. Liquid chromatography basically talks about the liquid state. Okay. This is used in everything. It can be used in pharmacokinetics, that means pharmacological, medicinal, proteomic, drug development, toxins, pesticides, herbicides, food, forensic, all kinds of things, everywhere you can use that. So, just have a look at this. This is the mobile phase, whatever the solvent you are using. So, that one, and you put into the pump because to pressurize, to push it, okay. And this pressure in the liquid chromatography is not very high. I will tell you in a while that one. And then from here it goes into the injector, and this injector will, at that stage you bring this sample. So, your flow, the mobile phase, and the sample will mix here, and that will get into the column. So, this is the guy who does the separation basically. The column is the one which does the separation. Now, that is where actually chromatography principle is working and happening. Separation is happening in this. So, that is what is the stationary phase. Already you have the mobile phase, and the so something comes first, something comes next, something comes later, etc. That is what you have seen in the previous slide here. So, you can see that. So, that order in which it comes, that is what you are looking at, and then goes into the detector, and then once it goes to the detector and measure, it will be out. So, you will not make it, you refer it as a waste, you are collecting into that. So, the advantage of this is you can use very small tiny concentrations like micrograms, picograms, some cases even much lower than that, by using better techniques than the simple LC. Okay. They are based on the LC, but they are more expedited procedures, which I will explain you in the next few slides. So, one can connect to the detector, as said, a lot, and most often in the recent days people are using the mass spectral. Then you will get the mass of each of that particular fraction that you are measuring. Therefore, from the mass you can try to identify. Now, here this is nothing but a chromatogram coming from that. Initially started here, you started pushing this the mobile phase along with the sample, nothing comes up to here. So, this is the time. So, up to 6-7 minutes nothing much has come. Then around that you started seeing some peak, the peak is closed, again nothing is there, again another peak has come, and nothing is there, again another peak has come. So, that means you have 3 different kinds of compounds, 3 different nature of the compounds are present, and each of these is coming out, one in A, another in B, another in C. Okay. So, you can collect up to here and separate it, you can collect up to these fractions, you can separate it, you can collect up to these, separate it. So, that means your separation is over now. So, that is how it is. You can also do the detection part simultaneously. I hope that part is clear. Very simple basic principle of the liquid chromatography. Now, you use a low pressures there, and if you go for a higher pressures, that is high pressure liquid chromatography, that means the pump that you are using will push the liquid much faster with much pressure kind of thing, so that it applies a pressure when it passes through the column. More or less principle wise the same. You have your solvent phase, you have your pump which is called peristaltic pump, which will push the liquid, pressurizes the liquid, and then goes into the column. Of course, you before it goes to the column you have to inject your sample, and then the outcome comes into the detector, and then it is connected by this, exactly the same. What is difference is the speed at which you are pushing the flow of the mobile phase, and some changes in the column. One is column material, not so much so, but column length, column diameter, these kind of things. So, those are the things. So, you make the little bit smaller and 4.6 millimeter diameter, stainless steel, glass, titanium or polymer, combination of these. This is packed with the particles of 3, 5 and 10 micrometer size. So, you use a higher pressures. The pressures which you use in LC are below 50 atmospheres, and here you use above 300, 400, 500, etc. So, continuous controlled flow, detecting very small amounts, high resolution than the LC, speed, efficiency, sensitivity and ease of operation. So, you can, because you are pushing the liquid very fast, you can also make it better, but of course, the separation is done more by your column. The column size, column length can also be adjusted. So, high degree of versatility, easy separation of variety of chemical compounds as compared to LC. So, you are trying to compare between the technique of LC and the HPLC, etc. in this. So, as you have seen that the column size and the pressure. So, LC, then HPLC. Let us see any other technique that you can. Okay, so just an example before we go to any other higher level of technique, HPLC, and this is an application applied on some essential oils, okay, and it is a HPLC resolution of a standard mixture of sesquiterpenes, is a mixture of compounds. What they have used, LiCHROSORB. This is the name, comes from the company for that column material. So, you do not need to mug or anything, and that is the RP18. And what is the medium they have used? What is the flow they have used? 85% acetonitrile in water. That means 85% of acetonitrile, 15% of water together. And what kind of flow rate? 2 ml per minute. So, for peak identification, you can see you are getting 1 peak, 2, 3, each one of these is a different compound. How do we know? You have to characterize. So, people have done characterization of all of these. As you can see here, the peak 1 correspond to this moiety, the peak 2 correspond to this moiety, peak 3 correspond to this moiety, etc. You can see all these compounds. By other methods they have done, because they have isolated, separated, they can do the characterization. Sometimes you can do by, you can connect it to NMR, you can connect to mass, most often they do with the mass spectrometry kind of thing. So you can see each one of these peak is a one different compound, is a mixture, the mixture which comes from the separation of a sesquiterpenes fragment or fraction of that. So you can see all of this. Such kind of things can be done. Now, is there any technique beyond the HPLC? Yes, that is what is called the UPLC, ultra high performance. So so this is ultra high performance liquid chromatography. So you can also say UHPLC, but UPLC in short form. So it's basically doing a high performance thing. So how will it differ? Suppose you look at the HPLC peak, and for the same you look at the UPLC peak. So what is the differences you are seeing here? The difference you are seeing is that the width of the peak is sharper and the height of the peak is taller. So that is where. So how did you get? So you can get by changing the speed at which this liquid is flowing through, and also the column that you are using, the column, and these are the things which will bring the separation part of it. Okay. So the ultra performance or ultra high performance liquid chromatography is a combination of 1.7 micrometer reverse phase column is used, and use 6,000 to 15,000. So this is around 50 psi. This is around few thousands, hundreds of psi, like and this is few thousands psi. See, that is where you have. So this is done. So the range and the column material size, particle size is also an important, how it is packed, this 3 to 5 micron packing, and this is operating between. So in HPLC you have a 3 to 5 micron, whereas in the UPLC you see 1.7 micrometer, 3 to 5 micrometer, and is much beyond. So you're looking at, you're changing the material, the particle sizes, and working on all that. So using that one, you can make ultra speed, you can make speed with resolution, you can resolve with the speed, you can have ultra resolutions as well. So this will give you the level of the UPLC for greater resolution, higher sensitivity, and faster speed. So you see that this can come with, depending upon what kind of a resolution that you require, you can choose any of these ones. You can choose. So this comes in short period 1.5 minute, this comes with 7 minutes, and you have to look at the whether you wanted a sharper one, whether you want to, you're in some cases you don't require very sharp one, you can be happy with this. So all these 4 combinations are possible with the UPLC, which is a modification of the HPLC. It is not a new principle or anything, it's the same modified. So you can choose which is the best for your system and utilize that one. Okay, so we have looked at the liquid chromatography and its modifications. Now you can look at the gas chromatography. Gas chromatography is, number one is that the gas is the carrier and gas is the flow system. So you can see this is the tank and goes, and this is the controls. Then you put your sample here and then pass it through your column. And in what you do is, here itself, this port itself is heated so much that the sample is evaporated and then goes into this. No, it does not go outside, it goes into inside. So it goes into the thing, and this is the column which has a material, and this will separate it out and then signal. Okay, so that you have 1, 2, 3, 4, 5, etc. Here these numbers are mass spectral numbers, and that means this particular chromatogram given is from gas chromatography connected with a detector called mass spectrometer. So that is where you are getting. So this is very highly used in lot of industries because it's somewhat cheaper, somewhat quicker to do for many other things. Any kind of impurity is present in the food, and quality control, research, forensics, air pollution, blood alcohol analysis, variety of these things can be done. So these are all done with these kind of things. What kind of, as I told you towards the end of this particular class, I will tell you about the detectors and mass spectrometry is used almost in everything, both with the liquid chromatography, gas chromatography. When I say liquid, HPLC, UPLC, simple LC, all are covered in that, and gas chromatography. Okay. So, when you do into detection, the samples may be recovered, may not be recovered. For example, if you put into the mass spectrometer, they are not recovered obviously. In some cases, yes, you can recover too. So, liquid chromatography, you can use light scattering procedure, you can use UV absorption, you can use fluorescence emission, you can use refractive index, you can use optical rotation where you have the optical components coming out, you can use conductivity. Nowadays, these are all much less used, and in some labs people use the radioactivity also, and quite a few. I do not think this is an exhaustive list of that. Of all these are non-destroying, so that means you can recover. Gas chromatography, flame ionization detector, flame photometric detector, nitrogen phosphorus detector, that is called phosphor detector, atomic emission, thermal conductivity detector, electron capture detector, photoionization. Variety of the detectors are there used, and but all of these techniques are used along with the mass spectrometric kind of thing. Okay. So, with this I would like to draw your attention particularly to look at, to get yourself more acquainted with this system, with the system of chromatography, with the knowledge of chromatography, so that you can enhance your knowledge by extended practice of this operation. Okay. So, practice, I have already given you a little bit on the detectors, but many more things are there. So, what I wanted you is, how will you practice these things? Just take one of the examples. You practice by collecting the data regarding these detectors used in each of these separation techniques. So, I just told a few, but you can look at all the separation techniques in that and prepare a very grand table for comparison. So, this is the technique, these are the kinds of detectors used, and these are the kinds of the sensitivity level. So, you write the sensitivity also. So, the technique, the detectors, the sensitivity, okay, and then you can draw your conclusions as which of these techniques are more commonly used across, and make a plot of detection method versus the frequency, how frequently they are used. Frequency means how frequently they are used, not the frequency of the light. So, how frequently they are used. Some of the techniques are used very frequently, very routinely. Some of them are used less frequently, less routinely. Okay. So, you should be able to differentiate all that. That will give you a knowledge, idea, future scope. If you are planning to open your own startup company, then you can really put your mind what kind of things would be beneficial, useful, most useful, so that you can think of in making your own judgment to get these ones. Okay, another practice session I would like to give you is search and fetch the genesis of the chromatography term itself with your own justification, so that you can appreciate the phenomena. Towards the end, I explained to you the HPLC and UPLC. These have been very extensively used for the separation and quantification of variety of molecules, chemicals, all those kinds of things, or many things from food. So, taken one type or category of food, you take any one of that of your choice and list the chemicals identified using the technique. Could be HPLC or UPLC. Compared to LC, people use HPLC and UPLCs more. So, list the chemicals identified in that category of food as studied by HPLC or UPLC. Comment on your understanding. What kind of impurities, additives? You see, you take so many kinds of food materials. They use color agents for color. They use flavor agents, so flavored molecule. So, to get a good flavor. So, these are all some chemicals. So, you can analyze and see what kind of things they are. So, any kind of a food that is left to you choice, and for all of that the data is available in the literature, you can do that. So, comment on your understanding of that. Okay, so, I have shown you all these examples, principles, etc. If you still wanted or still have some kind of a doubt, want to understand better by animation, I would refer you to go through that, but make sure that the animations are not true versions of the reality. So, that you have to keep in mind. So, you can also search any other short videos to visualize on each of these subtopic, you can see. So, you can always use all of them kind of thing. Okay, so, I think in the previous class plus this class put together, I have given you an idea of separation techniques, purification techniques, in principle, in particular focused on the chromatography, which can be used for the routine chemistry type samples coming from research, coming from food forensic, environment, water, pollution, any kind of things, and on the other side biological proteins and other kind of samples. Their separation, their techniques, methodologies, principles on which they are applications, all of that, and then finally showed you the chromatogram and how they function, where you can have a leverage, you can try to change certain parameters and make the chromatography method more resolvable, more sharper, more sensitive. Sharper means sensitive, resolve means peaks getting separated out, that is called resolution. Getting vertical, the x axis will separation will be resolution, y axis getting taller is the sensitivity. So, sensitivity and resolution, how to improve both of them, and at the same time one more thing hidden is how long it takes. It takes one sample taking whole day, one sample taking a 1 hour, one sample taking 1 minute. Obviously, these are all different. So, 1 day versus 1 hour versus 1 minute. So, these are all different. So, time gain is also important, so that you can do more number of samples in a given time, and sensitivity and the separation means resolution. So, these are the 3 major things that are played in chromatography, and if you understand these 3, you can have your own startup and gain, you can make profits out of that. Okay. So, I hope this clarifies at a very basic level the chromatography aspects, which can be used for both for the small molecular systems as well as the large molecular system. So, thank you very much.